Good day, my name is Peter Lucas. The lecturer for the following course is Troubleshooting Fault in Televisions. The course is TAEASS401B, Part B, and the unit of competency is UEENEEH171A. And as I said before, this is troubleshoot fault in television circuit. The objective today is to cover all three elements in the unit of competency. Now the first part that we need to discuss in this one is the power supply. The second element would be part of the circuit analysis. And then the third part is looking at fault finding of all these different circuits. We have got a few scenarios that we will be presenting to the students. This course has been adapted for online application. So let's start with the power supply, which is actually the most important part of the television. It works the hardest and it needs to service all the other different circuits inside the television. As you can imagine, the television gets powered from an AC source. AC stands for alternating current, and this is directly linked to the power coming out of your wall socket. This is normally 220 volts AC at a frequency of 50 Hertz. The power comes into the television and gets filtered. The filtering is necessary because of external interference. After the power supply has been filtered, the AC waveform has been filtered, it gets rectified. Because most of the television inside works off DC voltage. So it gets rectified from AC to DC. Once it's been rectified, it needs to be regulated. Because after rectification, you are sitting with 310 volts DC. And that needs to be regulated. In the power supply, you will find that it's actually an isolated power supply, which prevents you from having faults in the secondary side that gets carried over to the primary side. The secondary side is responsible then for all the voltages that is required for the different circuits. The 5 volts would, for example, go to little ICs. The 12 volts would go to the audio circuit. The 28 volts that is coming out of the power supply will be supplying the vertical circuit. Then you have the 115 volts, which normally supplies the horizontal circuit. And then out of the horizontal circuit, the secondary side of the horizontal circuit, you will find 300 volts or 400 volts coming out of there and supplying the RGB circuit. So now that we've actually had a look at the power supply, we will start analyzing the different circuits inside the television. The first circuit to look at is the tuner circuit. Now the tuner circuit is the part, let me just put a little antenna there for you. The tuner circuit is the it's a little silver box inside the television, and it's normally covered with metal plates due to the fact of external interference. Now that is the part also that your antenna gets hooked onto. Normally your antenna would be a UHF antenna or a VHF antenna. And that gets, that's a 75 ohm impedance cable that brings it down into the tuner. From the tuner, we go into the IF stage, which is intermediate frequency stage, and this is where it becomes very interesting. Out of the IF stage, or the intermediate frequency stage, we get quite a few different outputs. The first output that you will get out of the IF stage is a AV signal. When the signal comes in to the IF stage, it basically looks something like that. It's just little lines, squiggles and absolutely no, it looks like there's no intelligence inside of it. As it goes out of the IF stage, it goes into the AV stage, and now it looks a little bit more intelligent. It would have a sync pulse. There's your little sync pulse. It's got its chrominance, and it's also got all of its luminance. The other output of the IF is the audio. In the IF stage, it starts separating the video and the audio components. Once it's got the audio component out of there, it goes into an audio oscillator. This is where we generate a very small signal, and that gets fed into the audio output, which ends up in a little speaker. 8 ohms, 4 ohms, 16 ohms is a typical value of the little speaker. The audio output circuit can also take the shape of a little IC, integrated circuit, or 2 transistors, normally a class B setup. Now once it goes out of the IF, there's a third output, which is the most important one for us, because the whole aim of a television is to actually have a picture on the screen. So now we've got sound, but we need to get some video out of it. Out of the IF, that little signal that we used to have, as I said before, now it's got a little bit of intelligence. It's got sync, a horizontal sync, it's got chrominance, it's got all the luminance in there, and it's also got vertical in there. All of that goes into a chip called the jungle chip. The jungle chip is called the jungle chip for one specific reason, because it's got the sync separator pulse in there, it's got the horizontal oscillator pulse in there, it's got the vertical pulse in there, it's got luminance in there, it's got chrominance in there. It basically does a lot of stuff, and that's why they call it the jungle chip, is because it's got all of that it needs to generate and shoot off to all the other different stages. So once the signal comes out of here, a certain portion of the signal, and the signal that goes to the luminance and chrominance circuit would look something like this. This is your color, and this is your chrominance bars. Luminance bars. So the first thing that happens is the signal coming out of the jungle chip goes into the luminance circuit, and the luminance circuit, without the color circuit, you would have a black and white picture. Black and white television hasn't got color. The next part that we need to discuss is so now we have a signal in the luminance circuit that looks something like that. As it's going through the color circuit, and the color track is 4.43 megahertz. That is the color frequency. Once the black and white signal goes through the color circuit, now the colors gets mixed. So now we don't just have black and white picture, we now have a color picture. So you have cyan, red, blue, green, all of those colors. That signal goes into a circuit called the RGB. The RGB is responsible for mixing the colors inside the tube. So if you mix RGB, red, green and blue colors, which is your prime colors, you end up with a white color. Okay, that colors get fed onto the cathode of the tube, and that gets projected onto the shadow mask of the television. Now the other two signals that comes out of the jungle chip is the horizontal sync pulse and the vertical sync pulse. Now the horizontal sync pulse looks something like that. Now this pulse size is very important. It's 300 millivolts. If this pulse is too small, you will have horizontal sync rolling, which means that your picture will be unstable. Your picture will be going from left to right on the screen or from right to left on the screen. So there is your horizontal sync pulse, which is 300 millivolt. That signal goes in, which is the horizontal oscillator. It goes into the horizontal output. Now the horizontal output is a very high voltage circuit, a very dangerous circuit. In this circuit we have a step-up transformer. The step-up transformer is responsible for the high voltage which goes into the anode of the television tube. The maximum voltage that's allowed into the tube is 28.5 kV. Please be very careful when you handle this part of the tube. 28.5 kV is the cut-off voltage. After 28.5 kV, you will start getting radiation. So just be careful not to work too close to a television, especially a computer monitor that's got the old CRT tube. The frequency for the horizontal, to be able to switch this transformer on and off at a high frequency to generate this 28.5 kV is 15.625 Hz or 15.625 kilohertz. The output ends up also into what we call scan coils. Now the scan coils is connected around the neck of the tube. They are the two coils that's actually vertical on the tube. So let's feed it a little bit back. We come back to the jungle chip. Now the other output, which is also very important, is the vertical oscillator. Now the vertical oscillator also looks like a sync pulse, but it's just very small. After the vertical oscillator pulse, it goes into the vertical output circuit. Now the vertical output circuit is responsible for the frame of the picture. What is different from normal viewing of what is horizontal and vertical, on a television, horizontal, we normally know is horizontal is this form. But on a television, horizontal is actually straight up. Vertical is a flat line like that. So if you have a television screen, so if this is the television screen and you have a line going from top to bottom, you know that you've got a horizontal output problem. If you have a line across the screen from left to right, that is known as a vertical collapse, and you know that you have a problem in your vertical circuit. Words that can substitute horizontal output is also known as line stage, and vertical circuit is also known as frame circuit. Just to get back to the vertical output circuit, the vertical output circuit has got two waveforms on the coils. So on the one side of the coil, it will have a ramp, and on the opposite side of the coil, it's got a little pattern that looks like that. And this here, you have that. So on both sides of the scan coils, horizontal or vertical, you will see that the waveform actually gets bent. From a nice square waveform on the horizontal side, it turns into little saw teeth. On the vertical circuit, you have a ramp waveform, and on the opposite of the coil, you would have a pattern